Hi, everyone, and welcome to our webinar, VMware Cloud on AWS, Demystifying the Use Cases, presented jointly by AHEAD and AWS. We appreciate you carving out the time to participate in this important and timely discussion. And we do want to hear your questions, but just as a heads up, we'll do the Q&A at the end, as all phone lines are muted. So if you do have questions, submit them throughout the webinar using the questions panel, not the chat panel. We will collect those questions, and I'll be asking them of our two presenters at the end. If by chance we're running short on time and we don't get to everyone's questions, just another heads up, we will be writing a blog post as a follow-up where we answer all the questions that came through in writing. So let me introduce our speakers to begin with. Eric Shanks is a solutions principal at AHEAD with more than 15 years of experience working across data centers and cloud infrastructures. He's obtained 2 VMware expert certifications and 5 on the AWS platform. At AHEAD, he specializes in stitching public cloud with enterprise solutions. Joining Eric is Shay Lutton. He was a builder and innovator, having spent 10 years building solutions in high-frequency trading and has worked at several tech startups. As a cloud infrastructure architect at AWS, Shay specializes in using the AWS platform to build innovative solutions to complex challenges. Okay, so let's get started with today's webinar. Shay, over to you.
Thanks, Tom. Hello, everyone joining. My name is Shay Lutton. I'm a senior cloud architect for AWS in Chicago, and I'm joined by...
I'm Eric Shanks, and I'm a solutions principal with AHEAD.
Thanks, Eric. And we're going to talk through VMware Cloud on AWS. VMware obviously revolutionized data center efficiency when it was launched, and the AWS platform introduced great agility and scale. And combining these two technologies is an easy way to extend the benefits of both to your organization. Today, we're going to talk through the advantages of using VMware on AWS, talk through some of the use cases that make the most sense, and then Eric's going to walk through some demos of how easy it is to work in the environment and also to actually move some workloads. Big themes for today are going to be how to maintain your investment in VMware and the tools you've already earned and built skills in, how to gain speed and agility migrating to the cloud, and how to break away from the cost of maintaining data centers. So for people that haven't actually explored VMware Cloud yet, the beauty is that you actually already know how this tool works. This is the same software-defined data center that you use today, and this is VMware delivered, supported, and sold. This is the familiar process with VMware. And one of the nice things about this actually is that since it's maintained by VMware, they do all the upgrades and the maintenance. How many times have you heard from your teams that you have to upgrade a piece of your VMware cluster before you can actually do what you're trying to do? Eric, has that been a problem for customers?
Yeah, commonly there's a compatibility matrix that you have to go through and make sure that all of the pieces that you're using, say NSX or vSAN or vRealize Automation, match your vCenter versions. You have to go through that compatibility matrix long before you do your upgrades.
Yeah.
It's painful.
And it seems like it's sort of always in the way. So this is one of the nice features, is that you don't have to bother with that. This is a VMware supported product with the structure, the tooling, and the support that you expect. So let's start to get into the way this works here. Starting at the bottom, this is AWS bare metal infrastructure. This is ESXi running on bare metal hardware. This is not running on an EC2 instance, meaning that this is not a stack of hypervisors. This is ESXi on bare metal. And then on top of that, you've got vSAN, NSX, and vSphere for the storage, the networking, and the management tools that you're familiar with. This is the high-level view. Let's get a little more in-depth here. You can see in the middle, you've got VMware Cloud. The left side is your existing data center, and the right side is AWS native services. And this chart really identifies the power and the benefit of using VMware Cloud. You get all the same tools, but you get access to the native AWS services. So the AWS IoT platform to integrate and extend all your edge devices. You've got access to EC2 and S3 for nearly infinite compute and storage capacity. RDS is there. This is one of the major advantages. You can ramp up and down databases as you need them with about 1/10 the cost of major enterprise databases. This is ideal for both your production databases, but also for any development that you're doing. Furthermore, you've got access to things like SageMaker for machine learning. It's just the full platform of AWS is available to you to accelerate your work, to accelerate your innovation. And if you look at the top of this slide, you can see again all the familiar tools: Terraform, Puppet, Chef, Ansible, CloudFormation. These are the tools that you use for management, for DevOps, for infrastructure as code, the same as your organization has been, same tools your organization's been using. I want to make sure that there's no bait and switch here. I want to point out how this is billed. VMware charges you for VMware Cloud. Any native AWS services that you use are billed as a pay-as-you-go. So if you don't use EC2 and you don't use S3, there's no charge for it. But if you do want to use those services, you'll receive billing from those for those services through AWS. So I just want to make sure that that's clear. This is also a great time if you don't have a tagging strategy. This is a great time to introduce a tagging strategy so that you can do chargeback and showback for your applications. It's a great way to drive fiscal discipline for your organization. And that's commonly we see a lot of our customers start to integrate really in-depth and unified tagging strategies at this point. So why VMware in the cloud instead of in your data center? A lot of the perks here, you get great elasticity for burst capacity, for scaling in and out when you need. You don't have to spend the time to predict what capacity you're going to need in advance. It always ends up that in the middle of a billing cycle, you need more capacity anyway. So you can switch from a CapEx model to a variable cost model, and that has a lot of positive benefits for many of our customers. We touched on the vSphere hygiene, right? The fact that this is comes with all the software upgrades and maintenance built in. And as new hardware becomes available, you can roll right into that new hardware. So continue to accelerate the infrastructure that your platform is running on. And another major benefit that isn't maybe immediately obvious, you can actually use VMware Cloud to move closer to your customers. So you can push workloads to the regions where your developers or where your customer base is. And for medium or small enterprises that didn't necessarily have the breadth or the reach to be able to expand globally, you can't just spin up a data center in Sydney. That's hard to do. Now with VMware Cloud, you can expand to London or Frankfurt or Sydney or Tokyo or several locations in the United States within minutes. So that's a major benefit. What are the business outcomes? At AWS, we like to talk about what are the business outcomes and how do we work backwards from those. Why would you use VMware Cloud instead of just staying where you are in your data center? Using VMware in the cloud means simplified operations and one pane of glass. There's no loss of visibility here. That's one of the keys. And the common tool sets means that you gain agility and fast deployments. You don't have to take time to relearn to build up those skills. A simplified approach means accelerated migrations. So a lot of this is all about speed. And lastly, native AWS service integrations means a lower cost platform and greater flexibility. These are the themes that I touched on in the beginning. You get to break away from the high cost of data centers, maintain that investment in VMware, and achieve greater agility by moving into the cloud. I want to take a moment and call out the level of commitment that AWS and VMware have here. Last week was reInvent, and when Andy Jassy took the stage, the CEO of AWS, he chose to make VMware Cloud his closing message. He invited Patrick Gelsinger to the stage and spent his final 15 minutes talking about their partnership and the innovation and the effort that's being made by both companies. So this is not a little side project. This is the closing message by Andy Jassy at reInvent this year. This is going to be a very big deal. And so if there's any question about the direction that AWS is going, this is key in our messaging. And I also want to call out migration speed here. If you're considering taking the time to refactor or maybe re-architect an application, strongly consider using VMware Cloud, because it's a great way to be able to accelerate your migration. We've had customers migrate over 100 virtual machines in a single day. And one of the AWS higher ed customers moved 200 workloads, right? All the components of that workload in 96 hours. If you have a timeline that you're working on or that you need to consider, such as closing a data center or major network line leases that are coming up for renewal, these are great clarifying events. You can move fast by using VMware Cloud. We're going to talk through the use cases, but before I get to use cases, I want to call out who's really the core target audience here. If your company wants to move quickly or you don't want to refactor applications, VMware Cloud is for you. If you want to maximize the existing technology skills that you have, same thing. If you've got a cloud mandate or you've got a capacity crunch, this is key, right? VMware Cloud is great for all of those use cases. For operational profiles, companies that are heavily virtualized, if you've got over 50% of your machines are virtualized, this is an ideal setup. The same if you are using or you want to move towards using NSX or vSAN. They're not prerequisites, but these are great ways to step into those tools. So I said we talk more about the target use cases. The first one here, what we see a lot of our customers looking at VMware Cloud for is simplified DR. Many companies view their DR site as a very expensive insurance policy, and this is an ideal way to lower the cost of that insurance policy. Or some companies, they know they've always wanted a DR site but don't have one. This is an ideal way to extend that capability to a new region, to a remote location where you get some flexibility. It's also an ideal way to actually test your DR. Many companies have best of intentions, and every time in my professional career that I was looking to migrate or fail something over that hadn't been tested in a while, it never went as smoothly as I wanted it to. Testing repeatedly is the key. Make sure you can fail things over. And this is a really good way to have that capability at a reasonable cost without having to have a full separate data center standing by for DR capability. If you have capacity challenges, vSphere bursting is an ideal use case as well. By being able to scale up and scale down, that's right in the wheelhouse. You can extend that capacity when you need it and ramp it back down. Eric's actually going to show this in his demo, so we'll touch on that in a few minutes. One of the things Eric pointed out to me was that it really makes cloud licensing easier. If you have licenses that you've invested in, especially with vendors that are starting to be hostile to business needs around cloud usage, this is a good way to maintain those investments and to not have to refactor or think about how that licensing is going to apply. Mergers and acquisitions can actually greatly benefit from this. M&A activity, whether you are purchasing or selling organizations, M&A activity is much easier when you can easily blend or mix and match the technology. So that's an interesting use case. That's not everyone. It's a specific niche, but it's something that is a really nice plus if that applies to you. Scaling global resources, you get to easily extend your physical locations. You can spin up new regions, new locations very, very quickly, and that's powerful. Stay close to where your customers are to increase their end performance. And lastly, another big obvious case, if you have a data center that you need to get out of, either your primary data center or a backup data center, this is a really good way to accelerate those migrations. We talk with both of our customers. Eric and I are both consultants. we coach our customers how to move quickly, and this is a key way that we recommend doing that. So Eric is going to take over now and talk to you about the setup for our demonstration.
So here at AHEAD in our lab, we use a fictional company called AHEAD Aviation. So for the purposes of these demos, we're going to go through a couple of them to talk about some of the use cases. And here our fictional CIO has requirements that he needs. He's got a DR site contract expiring in the first quarter of next year. So the questions are, do we purchase a new contract or do we have other options? Also, the CIO wants to cut resource costs for application development. So typically, application developers have a bunch of servers on-prem, and you have to pay for those whether they're being used or not. If an application needs additional resources, you have to have them there waiting and ready to be used. And when you're not doing any development, they're sitting there just eating up money. And then lastly, of course, we want to limit the disruption of services. So obviously, we don't want to have downtime. It's important for our mission critical application that we'll be demoing to stay up. So we're going to try and limit the amount of downtime as much as possible. I also want to point out that there's a list of things here that we're going to be able to get to, but the journey is not going to end with the demos that we've got here. So the demos we're going to focus on here, we're going to start off with DR as a service. We're going to also show that you can use VMware Cloud to provide scalable infrastructure. And we're going to do some application development and some experimentation with AWS native services as well. But you can keep going and you can extend your data center through the use of hybrid cloud extension or NSX, as well as you can shut down your data center eventually. And maybe that's you shut down your DR data center, or maybe it's you shut down your production data center when you're ready. So just a couple of architecture designs here before we jump into the demo. I want to show you what we're going to be building. The first demo that we'll be doing here, you can see on the left-hand side, we've got our on-premises data center. We've got a couple of VMs, but you can assume that's a fleet of VMs or your farm of VMs. We're going to use VMware Site Recovery Manager to migrate those VMs over to the AWS VMware Cloud side, where there you can see we're in the US East 1 region. And we've got a VPC there with a number of subnets. One of those subnets has our VMware Cloud on AWS software-defined data center. So we're going to move our VMs from on-prem into that SDDC. The second demo that we'll do right after that will be to start playing around with some native services on AWS and do some application development. So what we're going to do then is on the left-hand side, you can see our VPC with our software-defined data center. This is our VMware Cloud. And then on the right-hand side, you can see that that VPC is still there. We can use that VPC to deploy some additional resources. In our case, we're going to deploy load balancer and some containers running on EKS. And they'll be able to communicate with the back-end database that's still going to live on VMware Cloud on AWS. And it does this by using this elastic network interface that's in that VPC. So I believe without further ado, we'll switch over to a demo. And this demo was recorded last Friday. We recorded on VMware Cloud on AWS, and then we were able to give the engineers their lab back, so I wasn't taking it up today. So first things first, I want to give you a tour of what we're going to be seeing in VMware Cloud. We're going to log into our VMware Cloud Services portal. And this will be the part that's a little different that you maybe haven't seen before. So I just want to give you a quick tour. There's a list of services that VMware provides. We're focusing on VMware Cloud on AWS today. So we're going to click into the VMware Cloud on AWS service. And once this page loads, you're going to see that we have logged in to see our list of software-defined data centers. So if we had more data centers here, you'd see them listed. Right now, we only have a single software-defined data center, and you can see that it's in US East, which is in North Virginia. And we've got our AHEAD lab here. It gives you a little basic information about CPU, memory, and storage on this page. But then we're going to go ahead and click into that software-defined data center. And we'll see the resources from our VMware Cloud Lab. Here you can see a little bit more information. You can see we've got 3 hosts, which is the minimum for a production cluster. 249 gigahertz of CPU, 1.5 terabytes of memory, and 32 terabytes of storage. So that's what you can see out of the box. But if we need to, we can also click this button here to add a host. And here you can see what our current cluster capacity is, but assume we ran out of capacity, we need to add some more. The cloud's going to let us be elastic. So we can say add 3 additional hosts, and you can see what our per host capacity is, the added capacity we would be adding, and then the new cluster capacity. So it does the math for us here, which is kind of nice. So we can quickly see what we're going to get. And then if we click add hosts, it would start provisioning those in our existing cluster. Likewise, elasticity, we'd also want to be able to remove unwanted hosts or unneeded hosts. So there's also an option here where you can click remove host, and you'd be able to remove that host as well, so you can start saving some money. Now, if you're familiar with VMware, you probably know what DRS is. DRS lets you vMotion workloads from one host to another host if it's less busy. EDRS is elastic DRS, and it's a similar concept, but it lets you add hosts and remove hosts as needed based on how heavily utilized they are. So we have this disabled right now, but you can also use optimize for best performance or optimize for the lowest cost, depending on what your preference is. Next, we'll take a look at the networking and security tab. And here on the first screen, you're going to get an overview of what network and security is going to look like. So you can see here we've got a management gateway and a compute gateway. These are essentially routers or firewalls that sit in front of VMware Cloud and AWS. And management gateway protects the management components that are managed by vSphere, by VMware. So things like vCenter, NSX, Site Recovery Manager, they're all behind that management gateway. And then the compute gateway is essentially where your workloads would live. So if you deploy a new VM, they would be behind that compute gateway. And we can see we have some connectivity here. We don't have an IPsec VPN tunnel created, but we do have a direct connect set up between our lab and AWS and connected to the VPC. And then it's connected directly to our VMware Cloud on AWS. And then there at the bottom, you can see we have a connection from our software-defined data center, which is the VMware Cloud, over to our Amazon VPC. If we go down to network segments, you'll see we've got a list of networks here. This is where you would add networks that would show up as a port group in vCenter. So you would add those networks here. They would show up as routed networks if you're adding them from here. You can also see we've got some additional networks in here that show disconnected, but you can add additional networks through hybrid cloud extension and extend your existing networks over to the cloud. But any networks you add here would show up as a port group. You can also add VPNs and NATs here as well if you needed to do that. Again, we're using a direct connect. If we dive in a little further to the gateway firewall, you can see that there's 2 different firewalls listed here. There's a management gateway and there's a set of rules, and then there's a compute gateway. For us to access anything like our vCenter, you would have to open up a firewall rule so that we can say allow port 443 so that we can access those management components. We would similarly have to do the same thing with our compute gateway. So if we deploy a workload out there as a web server, we would have to go in and add a rule in here so that we could access those web servers through that gateway. The next option here, you'll see we have a distributed firewall. And the distributed firewall is not in use in our lab at the moment. It requires an NSX Advanced add-on license. So this does not come out of the box with VMware Cloud. But it's a nice option for you where you can actually put the firewall rules at the NIC level of your virtual machines. So even virtual machines that are already behind your gateways could be firewalled with this tool. So you could do some serious micro-segmentation with the distributed firewall. And this comes from NSXT, which is included with VMware Cloud. Just like any other firewall, you'll see we've got some groups. So I can group a list of IP addresses or subnets together, as well as virtual machines. So I can use those in my firewall rules. Likewise, I can also look at services, and if I've got a web server that's running on port 80 and port 443, I can group those together and just say web, and then I can say use my web rule in my firewall rules. We also have a few tools here that you can use for troubleshooting. So you can set up IPfix and port mirroring. So if you set up those collectors, it can help you with some network troubleshooting if you're looking to do that, or if you're just trying to collect additional data. And then further down on this screen, you're going to see we've got some system settings like DNS. So any settings you set here for DNS will be observed by your ESXi host and your vCenter. So if you happen to look at those when you get into vCenter, you'd see they should match. Below that, we can also see we've got public IPs. And those public IPs come directly from AWS that can be associated with your gateways. So you can use the AWS pool of public IPs and add those here as well. If you have a direct connect, you can add your direct connect here. Pay no attention to these advertised BGP routes. We've got a little routing issue in the lab still, but the direct connect could be added here. And then the connection that I mentioned about the software-defined data center being connected to the VPC, you'll see information about that here. And that includes your AWS account ID, the VPC it's connected to, and which subnet that ENI lives in. You'll also see some information here about some IAM roles, and those IAM roles are used to make changes in your AWS account on your behalf. Things like updating routes if an ENI changes or something like that. It basically makes your SDDC continue to run smoothly if there's changes that happen in your environment. And I think here we're going to move on to add-ons. So right now you only see 2 add-ons in this screen. I think you'll expect to see more add-ons in the future from VMware, but these are things that you can enable in your cloud, and usually these come with an additional cost. Site recovery right now has an additional cost associated with it, but on-prem you would deploy these components. In the cloud, you don't have that option because it's managed for you. So in this case, you just activate your add-on, and the site recovery tools would be deployed in the cloud for you automatically. And then you could download those on-premises components and install those in your vCenter to nail up the other side of your configuration. Hybrid Cloud Extension is another one you can use here to help extend your layer 2 networks. So that's another one and that one does come for free when you get your hybrid cloud. On the troubleshooting screen, this is a nice screen you can use. Right now it only shows the connectivity use cases of hybrid link mode, but there might be more of those in the future as well. But before you would set up hybrid link mode, you'd have to go in and make sure that your connectivity worked before you tried to set that up. Otherwise, you might continue to have failures. So this is a really nice screen where you can go in and set up or enter in your information for your primary DNS server, your secondary DNS server, your on-prem vCenter, your platform services controller, Active Directory, or one of your ESXi hosts, just to test your connectivity. You can put those in there, and then you could run all your tests, and it'll come back with a nice green check mark or a big red X telling you, yes, I can communicate properly, the firewall rules are set. On the settings screen, you're going to get some nice useful information for yourself. Things like the default vCenter user account is listed here, how you would access the vCenter or the client, the HTML client, and then maybe one of the big ones here is your Power CLI connection string. So if you're used to using Power CLI, you can find that information here, and it'll allow you to connect to your vCenter that's deployed in VMware Cloud. On the support screen, you're going to see some additional information that's useful for the support team from VMware. Things like your organization ID and your software-defined data center ID, really useful things for the support team so that they can access your cloud and do any troubleshooting. Also, the patch level of your cloud is listed here, which is a thing some people will keep an eye on. Speaking of support, though, in the bottom right-hand corner here, you can see a little icon, and if you were to happen to click on that, you'd be taken directly to a support chat window with VMware support technicians. And I can't say enough good things about this. It might be my favorite part of VMware Cloud on AWS. I've used this several times, and someone immediately comes back and starts talking to me. I don't think it's taken more than 2 minutes. If something can't get resolved right away, they'll open the tickets for you. You don't have to have a support contract or any ID or anything. If you have VMware Cloud on AWS, you have support so they can open tickets for you in the background. You don't really have to do anything. This is maybe my favorite feature. I like talking to support again. This is really nice. Okay, so enough of the new console stuff. Let's get into one of the actual demos for the use cases. If we click Open vCenter, this is going to get us access directly to our vCenter in the cloud. If you haven't done this before, it's going to give you a warning saying that, hey, you might need a firewall rule opened up. So you can click that button for the firewall rules, and it'll take you back there so you can update those. Next, we'll click Show vCenter Credentials. And again, you didn't deploy this vCenter, so you don't know how to log in. VMware will give you this information here with your default username and password. We've already set this up in our account with hybrid link mode, and we're connected to Active Directory, so I don't really need to use these. I'm just going to open the vCenter, and I'm already authenticated with my AD authentication. So this is a pretty underwhelming screen for you probably, because this is exactly what you're used to seeing on-prem. You can see we have hybrid linked mode set up in our vCenter, and we have two vCenters listed here, our Equinix vCenter, which is on-prem, and we've got a cluster with some resources there. And then you'll see that we've got the VMware Cloud and AWS software-defined data center, and we've got 3 hosts listed there. You'll also notice we have 2 resource pools, a compute and a management resource pool. The management resource pool is where all the management components VMware manages for you are at. vCenter, SRM, NSX, those types of things. And you'll notice that if you try to take action on any of those management resources, if we went to power off the SRM server, you'd see that they're grayed out. We don't have permission to act on those. Now, if we went to the compute resources where our workloads would be living, we do have permission to take action on those, so I could power those off or power them on, do what we need to do. So that's the reason for those 2 compute resources. Let's take a look at our first demo, though. And our first demo is going to be how do we move our workloads to VMware Cloud and AWS for disaster recovery. So the CIO is worried about his existing data center. Let's use site recovery as a method for us to replicate and move our workloads to VMware Cloud and only pay for the resources that we really need. So we'll go in and we'll click on our Open Site Recovery. And we're going to go ahead and log into Site Recovery Manager. Once the portal opens, you'll see that we've got a site pair already. So our Equinix data center on-prem is connected to our VMware Cloud and AWS side, and we can look at the details of those. So once I do that, I have to log in again. This is the login for the opposite side of the connection, just to make sure I've got the right permissions. And here again, you can see our summary of the site pairing. But we want to look at replication servers. So the replication servers are virtual appliances that are doing the replication for us in the background. And you can see we've got a list of replication servers here. After that, we'll look at folder mapping. So when a virtual machine fails over from one site to the other site, it's in one port group on one side. We need to say what port group it should live in on the other side. So we do that mapping ahead of time. There's also a test network. So if you're doing a test of a failover, it'll spin it up in an isolated network, in a bubble network. So you can test it without it being connected to the rest of your domain. So it won't see its original self, essentially. Folder mappings, we're going to do a very similar task here, where your virtual machine folders, you have a folder on your on-prem side, you have a folder in your VMware Cloud side. When things fail over, you need to know where they should live. And then resource mappings is very important for VMware Cloud. On-prem, we've got our resources in a cluster. In the cloud, we're going to have resources in a resource pool. So we need to make that mapping so we know where they'll live. If you're using vSAN, there's a storage policy mapping you can do as well. And then you have to set up a placeholder data store, which is essentially where you save your VMX files, even when those virtual machines aren't running. So it's got a temporary placement for those. If we look at replications, you can see I've got two servers here that are being replicated, a task app and a task DB. This is our mission critical application that we're going to get ready to move. And you can see we've got a forward replication here from on-prem into VMware Cloud on AWS. There's also reverse replications. This would be if it was from VMware Cloud on AWS back to on-prem, but we don't have those set up. Protection groups. Protection group is a list of virtual machines that should be failed over together. You're really just grouping those virtual machines together, but you need to set these up prior. And if we look at the protection group here, just to get some more details, you'll see that we've got 2 virtual machines listed here as part of our protection group. And then we're associating this protection group with a recovery plan, which we'll talk about in a minute. And then we've got those 2 virtual machines. You can see where they live and the mappings for those machines. If we look at the recovery plan, you'll see the recovery plan is a list of steps that are going to be taken when we do a failover or a migration. You'll get information here about where things are at in the migration, and you can create any scripts and modify these recovery steps if you need to. I have virtual machines placed in two different places here. I've got a database that's going to be in our priority 1 virtual machine, so it'll boot up first. And then later on, there's a power on priority 3 virtual machines, and that's going to be the application. Obviously, I want my database to come up before my web app comes up. So before we do the actual failover, let's take a look at the application and just prove that everything is working and in good shape on-prem before we do a move. So I'm looking for my task app application, and I'm going to go grab the IP address of that application. We're going to throw it into a web browser just to prove that the application is working on-prem. And we're going to log into our application. Again, this is our mission critical application that we have to keep running. And we've got a list of messages in here already that came from prior work. And what we're going to do here is we're going to post a message in the window and submit it just to prove that the application is working, it's communicating correctly with the backend database. And we're going to do this before we actually do the migration over to VMware Cloud on AWS. So we'll submit this. And it looks like it's working. So let's go back to Site Recovery Manager. And let's try and fail this over to VMware Cloud on AWS. We go back to our recovery plan. And we'll hit run. That's the big red button. This is all the marbles. So we're going to read this description, and it's going to let us know here that this is really going to take an outage when we do this. Like, we're going to power off the machines in our production site and move them to a different site. So we have to say, yes, I understand that. And then we have to select the type. So plan migration would be, hey, the vCenter is already working. We can do one more sync. The disaster recovery option would say, hey, the primary vCenter is not working at all, that maybe there's an issue or a real disaster. Just power on the VMs in the other site. But since our sites are working, we're going to use a planned migration. So we'll get a summary screen and we'll go ahead and click finish. And our recovery plan is going to kick off. So in just a second, we should see some new status messages about how the application's moving. So we're doing things like pre-synchronizing storage. Some of these don't make sense for VMware Cloud, but they're there for if you're doing on-prem to on-prem. So some of these steps actually get skipped. They'll show up as success. But we're shutting down the VMs at the production site, and we're getting ready to power on our priority 1 VMs. And while we're waiting for that, let's go ahead and take a look at vCenter again. You can see our applications have been powered off in the production data center. And if we go over to the VMware Cloud vCenter side, you can see at least one of our applications or one of our virtual machines is powering back on. So this should be that priority 1 VM. I'm expecting that the priority 1 VMs have already been started. Yeah, we're still in the running stage. So once VMware Tools reports back that it's up and running and hey, I'm good, the other virtual machine will kick in. While we're waiting for that, I just wanted to mention that there's another way you can do this. You can select an application on-prem, and since we're using Hybrid Cloud Extension, we can migrate to cloud right from the front panel. And we're going to have to select some additional folders here. And some of the mapping we did with Site Recovery Manager. This is a feature you can use from Hybrid Cloud Extension to do this move for you. It's free if you're using VMware Cloud on AWS. It's more of a migration tool than a disaster recovery tool. But I thought I would show it to you here while we're waiting on the other site recovery to finish. We do have an option to vMotion with this. And vMotion, basically, we're stretching our layer 2 network over to VMware Cloud. So this can actually be done with no downtime.
Cool.
Or very, very little downtime. You might miss a ping or two, similar to vMotion. So we'll see, hey, validation successful. You need to be on a hardware version 9 or later. Also, if you're on vSphere 6.7, that doesn't work yet. I'm sure it will any minute now. But the latest hardware version doesn't work yet either. Let's go ahead and take a look back at Site Recovery Manager and see if it's finished with its failover.
and bringing our virtual machines back up. So we're looking at status as the screen refreshes. Priority 3 VMs are powered on, so our database and our application are both up and running. And if we scroll up, we see that we got recovery is complete. So our failover completed successfully. Let's take a look at our applications in vCenter again. Both our apps are running, and you'll see we got the exact same IP address we had before. We'll copy that and throw it into the web browser again. So since we use layer 2 extension, we've got the exact same IP address that we had before. Nothing has changed from that. And we can see we've got a message in here already before we failed over. We did that last sync because it was a planned migration. We're going to enter in another message here just to prove that the application and the database are still both communicating with each other, even after they've been moved over to VMware Cloud. And they're working. So looks successful. Just to prove that there's no smoke and mirrors here or anything, we're going to go ahead and power off the database now. I know it's a mission critical app, but we'll take the hit. We'll power this thing off. And then once the virtual machine has completed its power off cycle, we'll go back to that same page and we're going to go ahead and enter in another message. And if things are correct, this message should fail. If it doesn't fail, then I am a really good architect. I don't know how I would have done this.
Does the database look down to anyone?
It's timing out. So internal server error. That's perfect. That's what was supposed to happen. So we proved that's working. So let's look at demo 2. Now that we've failed everything over, and maybe we've got a lot of workloads here, let's go and move things over to use some native services on AWS. And for this, our developers are saying, hey, we think we can change that web app over to a container. So we're going to build a new container, and we're going to deploy it on EKS. So let's go in, make a change to our application, and I'm going to just make a quick change to the header that's at the top of the web page, and we're going to change that to our brand new file. We're going to save the file, and then once we save that, we're going to commit our changes to Git, like we're supposed to do. So we'll add it to Git. We'll add a commit message here so that everyone knows what this is for. And then once we commit this, we're going to push it up to our GitHub repository. So we'll do a git push, and it's pushing it to our develop branch. Now, when anything hits our develop branch, we've got a webhook on our GitHub repository that's going to trigger a Jenkins build. So if we look over at Jenkins here, any second now, we should see our job run. Here we go. So we'll pull this open. And you can see that we've got some things that are happening in our pipeline. So this is actually going to build our container for us. And while we're waiting for that to happen, let's take a look at what we've got in the AWS side already. So we can run our containers, we're going to need to have some nodes deployed. So we did this through a managed service called Elastic Container Services for Kubernetes, or EKS. And you can see here we've got a Kubernetes cluster deployed. And along with that Kubernetes cluster, we've also got some nodes. So these nodes are going to be what runs those containers. If we look at EC2 instances, you can see we've got 3 different nodes here. That's going to be what runs our containers. And then we've also prepped a load balancer for those nodes. So if we scroll down a little further, we'll see that we've got a load balancer here. And if we were to take the DNS name of that load balancer and we threw that into a web page just to see if it was working, should see that that load balancer is not working. There's no containers behind it, so it's going to time out. It's going to give us a bad gateway. We've got an Nginx ingress controller, and that's it. There's no containers running webs. Looking at Jenkins, our build's done. So we have checked things out of Git. We went in and built the container. We pushed that container up to Docker Hub. And then if this was my master branch, it would have actually gone and deployed the container. But since it's just the develop branch, we're going to have to manually deploy this container on our own. So if we refresh our screen at Docker Hub, you should see that we've got a new tag. And there you go. We've got tag number 4. It was just pushed a minute ago. And now we need to take that container and push it to EKS and test our app. So we'll run kubectl, apply, and wait a second. We need to update our Kubernetes configuration before we deploy it. We need to go down and make sure that we're updating the right tag and deploying the right thing. So we'll go in here and we'll update the tag and save it. And then we'll push those containers to our EKS cluster. Remember, the database is still running on VMware Cloud on AWS. So we apply our configuration file, and we've got a new ingress controller, a deployment, as well as a service. And if we do a kubectl and we look at the deployments, we'll see that we can see a new deployment. There's 3 containers. They're all up to date and available, ready to go. So now, if we went back to our web browser and we looked at the load balancer, the exact same URL, now our web application is working. So at least the web page is working, the container is working. Let's post another quick message. And this message should be deployed to the database that still lives on VMware Cloud on AWS. And that database might still live on VMware Cloud on AWS for licensing purposes. You know, if you've got SQL licenses or something like that, a lot of times they're licensed at a host level. So if you're on-prem, that's no problem. Trying to move a SQL license to a shared tenancy model in AWS makes things a little trickier for licensing. But if you're using VMware Cloud on AWS, you're still using hosts there and you own the whole host. So you might be able to still use those licenses. Obviously, talk to your own licensing experts on whether or not that's okay with your ELA. So cool, it looks like the database is working and we've got a connection. Again, just to prove that things are living on VMware Cloud on AWS, and I'm not doing any trickery here with the webinar, we can power off our database server. And once it's powered off, we can look at our load balancer again and our app. And if we tried to post another message here, it should fail. Submit that. We'll wait for the timeout period. And again, we got a bad gateway. So that's our 2 demos. We get to do some applications in AWS, and we also get to do take advantage of the VMware Cloud on AWS side as well. So how would you get started with this? There's several ways you can get started. You can reach out to your AWS account team. You can also reach out to your VMware account team. Both of them will be very interested in helping you out with this. Or you can also talk with a partner like AHEAD, where we have certifications in both VMware Cloud, VMware, and AWS. And we will be able to show you where your workloads should live for your use cases, maybe some in both, but we can have that rationalization conversation at that point. A little bit more about AHEAD. We're a premier consulting partner. We've got expertise, like I mentioned, that you can trust on both VMware side and AWS. We've got accreditations and certifications in both, and that's our demo.
Thanks, Eric.
Okay, guys, Shay, Eric, thanks very much for the thorough walkthrough. I have a handful of questions I'd like to get through. For our attendees on the line, feel free to continue throwing some questions at us using the questions, not the chat window. So let me just jump in sort of order in which they first arrived. And apologies if some of these overlap with something you already answered. I may have missed that, but I'll ask them anyway. So a couple of questions around how is VMC actually getting deployed?
Sure. So first you'd have to talk to your AWS account reps to make sure you've paid for the service and things. Once the service is enabled, you deploy your SDDC right from the website. You can go into your console once you've got access to it, and it'll deploy as many hosts as you need. But you need to have at least 3 hosts to start. If you're doing a stretched cluster, and a stretched cluster for VMware Cloud means you've got hosts in more than one availability zone, so you could have them in 2 AZs, you would need to have 6 hosts at that point, 3 on each.
That is the way that AWS would absolutely recommend doing it. We built out these availability zones as totally independent clusters of data centers. So we highly recommend that you use more than one availability zone to have a really robust and reliable platform.
Okay, excellent. Thanks, guys. That answered another question that came in around the definition of a stretch cluster. So thanks for that, Eric. Can I migrate existing vSphere VMs to my VMC on AWS deployment?
Can you migrate them? Yes. So there's several ways that you can do migrations. Obviously, the rough and tough one is you can do a backup and a restore, but there's easier versions for VMware Cloud. So Site Recovery and Site Recovery Manager is a great one, especially if you're doing disaster recovery testing. But you can also use it for planned migrations. VMware even has a promotion out right now. You can move 200 VMs for free for 90 days. I don't know. I think that promotion goes till February, I think. So that's one option. You can also use Hybrid Cloud Extension, and that's a free tool from VMware. And in some cases, you can even vMotion your workloads from on-prem to the cloud with no downtime, no re-IPing or anything like that. But it's more of a migration tool and not disaster recovery.
Okay, thank you. Do you need to have your on-prem VMware clusters on the same versions as the VMware Cloud?
No. So those versions will change. You can assume in the future. If you want to take advantage of a no downtime vMotion, I think you have to be on 6.5. The cloud version is actually 6.7, I think. So they're already not matching. But you don't need to be on the same version. If you're doing Site Recovery Manager, I think you can also do previous versions. And HCX, I think you can go as far back as 5.5 or maybe even 5.1.
There's some flexibility there.
Yeah, but you would take an outage when you do your migration, I believe. You can't just do a vMotion.
Okay, 2 more questions, gentlemen. Is there a minimum cluster size that one must purchase in order to use VMC?
Yes. So a production cluster requires at least 3 hosts if you're using a single availability zone, and at least 6 hosts if you're using multiple availability zones. There's another option for a single host. It needs to be treated as a lab, and I think they limit that to 90 days. So you can try it out if you want to for a single host, 90-day trial, get everything set up and test drive it, and then see what you want to do from there. I think you can extend it to your 3 hosts at that point if you want to continue with it.
Okay. This one just came in. Do I need an AWS account in order to get into VMware Cloud on AWS? I assume to experiment, play around, et cetera. So.
Yeah, absolutely. So that's one thing that we don't talk about enough probably. You do need an AWS Cloud. When you go to set up your first software-defined data center, that the VMware Cloud on AWS lives within an Amazon VPC. To get a VPC, you need to have an AWS account. And that's pretty simple to do. You can do it with a credit card. And the VPC itself doesn't really cost you any money. But you should probably take some time and do some things like securing your cloud environment first before you deploy your VMware Cloud inside of it. Things like enabling CloudTrail logs, which are used to track your API calls and make sure that nobody's using your cloud for things that you didn't intend it to be used for. Locking some of that stuff down just to make sure you've got good governance before you deploy your VMware instances.
That's a good point. AWS makes setting up your first account easy, but we also do some things to, as part of that make it easy process that you'll want to think about. The VPC is your virtual private cloud. It's sort of the container in which most of the things that you build will live inside an AWS account. We create a default one for you. You're going to want to think about that and think about what networking do you actually want. You want to create your own, probably to use in any sort of production capacity, and that'll probably entail some conversations with your networking team and so on.
Okay, thanks, guys. Another question: how long does it take typically to spin up an entirely new cluster in VMC? Or what variables determine that, I guess? That's
an interesting question. I think it's probably on the availability of the hosts behind that generally. I don't think it's taken us very long. It's probably between an hour and 2 hours, I think, most of the time. But there's been changes too to the way that the VMware Cloud's been updated recently. They just switched from the old NSX-V over to NSX-T. So I'm not sure I can give you a good example of how long that really takes, because we've been seeing some transitions there too.
Certainly less than 2 to 3 hours most of the time.
Okay. Last question. AWS Outpost announced recently at reInvent. In general, how does that affect VMware strategy?
Yeah, that's a good question. It was a lot of fun to watch Andy Jassy announce that, and that's going to have some big implications. If you have an existing VMware cluster in an existing data center, Outposts might be a way that you could extend that capacity. Outposts are not actually going to be shipping until late 2019, so there's going to be some time and a lot more information is going to come out for them. They look like an ideal solution if you have new locations, if you've got a branch office that you want to add some capacity to or build out for the first time. And the idea there, because you can either have an AWS native outpost or a VMC outpost, it'll get you some flexibility to make sure that you've got the tools, the common tools that your organization has chosen to build with.
Yeah, Shay mentioned that the outposts can come in 2 flavors, at least that's the way it's being talked about now. So you can either use the AWS control plane where you're using the typical AWS APIs, or you can also use VMware Cloud on AWS on-prem on Outpost, right? So you're using VMware Cloud again, but you're using it in your own data center.
Awesome. That's all we have, guys. Thanks, everyone, for the questions out there, and thank you, Eric and Shay, for your wonderful insights. And to our audience, please be on the lookout for some follow-up materials as well as a link to a replay of this webinar. And of course, we'd like you to learn more about our company ahead at thinkahead.com. We want to hear from you, and thanks again for your time. Have a great day.
Thanks, everybody.